Hi, this video calculates an example of shear stress on a post that's protruding from a wall. Now, with stress and strain, physically the definition is stress is how a force is spread across some area. So in the case of a shear stress is a force that's applied along some sort of cross-section. And with a shear, the strain is the dimensionless response. The dimensionless response for a shear is how an object goes from being a rectangular parallel surface structure to more of a parallelogram type structure. What the strain is measuring is the deflection of the object compared to the height of the object. And for all stress-strain relationships, all stress is directly proportional to strain, and the proportionality is known as the modulus of elasticity. And modulus is really just a fancy word for slope. So think back, y equals mx plus b. Why do we use m? We use m for modulus. So for this piece, there's a 4.8 centimeter diameter aluminum post that's protruding 5.3 centimeters from a wall. And there's a 1,200 kilogram mass that's being suspended from the end of that post. Now, with moduli of elasticity, we're talking about material properties. And anytime you're working with material properties, it's absolutely essential to use the material property that you find in your textbook. It's one of the wonderful things about materials. There are a whole bunch of different materials out there. You'll find a range of values depending on the exact details of the material that we're working with. So in my textbook, the shear modulus for aluminum is given as 2.5 times 10 to the 10 newtons per meter squared, which is also 25 gigapascals. And you'll see pascals a lot for units of stress because a pascal is a unit of force per area, Newton per meter squared. And we'll run into pascals more when we talk about fluids and fluid pressure. So, for a shear stress, the force on our object divided by the cross-section is going to be the shear modulus of our material times the deflection divided by the height of the object that we're deflecting. So the force is being provided by this 1,200 kilogram mass. But remember, mass isn't a force. Mass is the amount of stuff. The force here is the weight of the object. And to calculate weight, weight is the mass of the object times the strength of gravity. 9.8 meters per second squared. So, solving for our displacement's going to be our weight times the height of our object divided by the cross-section. And here we have a circle. The cross-section of a circle, if we know the diameter, is pi over 4 times the diameter squared. And we're also dividing by the shear modulus. So if I plug in all of my numbers, I have a 0.053 meter extension, a 0.048 meter diameter. That gets squared, divided by that 25 gigapascals, 2.5 times 10 to the 10 Newton per meter squared. We end up with a deflection of 1.02 times 10 to the negative 5 meters, which is 10 microns, about 1/10 the diameter of one human hair. Thanks for watching.